Welcome to this explainer. Today, we are tackling a massive piece of the secure coding puzzle. We've talked a lot about input validation, and we've covered output encoding. But what happens when you're forced to accept messy, potentially dangerous data, and you just can't flat out reject it? Well, that is exactly where the third crucial technique in our secure coding toolkit steps in: data sanitization. We're going to break down exactly what it is, how it actually works, and the gold standard tools you need to get it right.
Okay, let's dive into this. Here's our roadmap for today. 1. The paradigm. 2. The rich text problem. 3. The mechanism. 4. The gold standard libraries. 5. Beyond HTML. And finally, 6. Traps and takeaways.
Let's kick things right off with Section 1, the paradigm, validation and beyond.
To really wrap our heads around this, we need to clarify where sanitization lives alongside your other tools. Think of these as your 3 layers of defense. Validation is your gatekeeper, right? It simply looks at data and decides to either accept it or reject it entirely. Encoding, on the other hand, is your translator. It transforms dangerous characters into a safe format for a specific output context. But sanitization? That is your filter. It actually removes or modifies the bad parts of the data while keeping the good parts intact. It's absolutely vital to understand that these aren't competing tools. They're a team. The golden rule here is validate what you can, sanitize what you absolutely must accept, and always encode on output.
Moving right along to Section 2, the rich text problem, when to sanitize.
So you might be wondering, when would we actually sanitize input instead of just slamming the door and rejecting it? Picture a forum, a user bio page, or a comment section. In those spaces, your users legitimately need to use basic formatting. They need bold text, italics, links, you name it, just to express themselves normally.
And this perfectly illustrates the ultimate developer tug-of-war. If we go with strict validation and reject all angle brackets, well, we completely break those legitimate HTML formatting tags. The app basically becomes unusable for normal people. But on the flip side, if we do absolutely no sanitation and blindly let those characters through, we are leaving the front door wide open for malicious users to inject script tags and event handlers. Boom, the app gets hacked. Sanitization is that elegant sweet spot right in the middle. We allow the safe, harmless formatting to pass through, and we silently strip away the danger.
So how do we actually pull off that middle ground? Let's look under the hood in Section 3, the mechanism, how sanitizers work.
A real, robust sanitizer doesn't just blindly scan for bad words. It's a 3-step process. Step 1, it fully parses that incoming input into a structured representation, basically an HTML parse tree. Step 2, it walks through that entire tree applying super strict whitelist rules. It knows exactly which tags are allowed, what attributes are okay for those tags, and even the allowed values for those attributes. Everything else, silently stripped out, gone. Step 3, it reconstructs a brand new, safe output from that cleaned up tree. By using a proper structural parser, the sanitizer makes sure it can't be tricked by weird encoding hacks or malformed HTML.
Which brings us to a piece of developer wisdom I absolutely love. HTML is not a regular language, so you cannot reliably parse it with regex. I know, we all love a clever, regular expression. But trying to parse HTML with regex isn't just a headache, it's incredibly dangerous. Attackers are smart. They can easily craft HTML that completely bypasses your regex using weird attributes or malformed syntax that your pattern just wasn't expecting. Seriously, never try to DIY this with regex.
Instead of DIYing it, we need to rely on the pros. Let's talk tools in Section 4, the gold standard libraries.
It is honestly fascinating to see the heavy lifting a good library does for you behind the scenes. When you plug in a proper sanitizer, it's relentlessly scrubbing out the nasty stuff to leave you with purely presentational HTML. We're talking completely nuking script tags. It strips out all those sneaky event handler attributes like onClick or onload. It digs into href and src attributes and rips out any JavaScript. So if a link tries to fire off a JavaScript :alert1, it's dead on arrival. It even strips out CSS expressions that might execute scripts and completely removes dangerous elements like iframes and embedded objects.
Okay, so what exactly should you install today? Well, it depends on your backend. If you're living in JavaScript land, whether that's the browser or Node, DOM Purify is your absolute gold standard. It has 0 dependencies and it's incredibly lightweight. Python developers, listen up. The old go-to was a library called Bleach, but that is officially deprecated. You want to switch to NH3. It's modern, it's secure, and it's way faster. And if you're building in Java, grab the OWASP Java HTML Sanitizer. It uses a really powerful policy-based approach, and it is literally battle-tested by Google in production. The takeaway here, stop guessing and adopt one of these immediately.
Now, let's zoom out for a second. Welcome to Section 5, Beyond HTML, Other Contexts. Because sanitization isn't just about web text.
One of the most overlooked, dangerous areas for developers is file uploads. The trap is so easy to fall into. If a user uploads a file and names it // password, and you blindly trust that file name, you've just handed them a path traversal attack. Or maybe they upload report.pdf.exe, which on a Windows server might execute as malware. The solution is remarkably straightforward. The absolute safest approach is to literally never trust the user's file name for storage. Just generate a random UUID for the actual file and save their original name as text in your database. If you absolutely positively must use their file name on the disk, you have to aggressively strip out all path separators and strictly enforce a whitelist of safe file extensions.
And there are plenty of other contexts where you have to sanitize. For instance, if you are passing user input into a shell command, and honestly, please exhaust literally every other architectural option before you do this, you must use proper shell escaping libraries, not just manual quotes. For LDAP queries, you have to escape filter characters. Here's a super clever one. When you're doing CSV exports, which can be vulnerable to formula injection attacks, if a cell starts with an equal sign, a plus, a minus, or an @ symbol, just prefix it with a simple tab character. That one invisible tab completely blocks a spreadsheet program from executing a malicious formula. And lastly, always normalize things like email addresses, like lowercasing the domain, before you validate them.
We have covered a lot of ground today. Let's bring it all home with Section 6, Traps and Takeaways, Secure Code Checklist.
Let's do a rapid-fire review of the classic anti-patterns you need to avoid. Number 1, like we said, regex-based HTML cleaning. Just say no. Number 2, using blacklists instead of whitelists. Trust me, attackers will always find that one weird, obscure attribute you forgot to block. Number 3 is actually a really fascinating edge case, double sanitization. You might think, hey, doing it twice is twice as safe. But actually, running a sanitizer multiple times can sometimes unexpectedly unescape data and create brand new vulnerabilities. Sanitize it once, then treat it as clean. And finally, number 4, do not assume that data sanitized for HTML is automatically safe everywhere else. It's safe for a web page, sure, but definitely not for a database query or a shell command.
And that brings us to the overarching philosophy of this entire explainer, defense in depth. Secure coding is all about combining multiple layers of security. You use sanitization to drastically reduce the risk when your app is forced to accept complex, rich input. But remember, that's just layer 1. Once you've safely sanitized and stored that data, you still absolutely must use output encoding when you display it back to the user. They work together to eliminate the risk.
I want to leave you with a thought to chew on today. Think about your own codebase right now. Your application probably handles rich text somewhere, user profiles, comments, document uploads, but are you relying on a true structural whitelist-based filter like DOM Purify or NH3? Or is your code out there right now just crossing its fingers and guessing with a regular expression? Go check those dependencies, swap out those deprecated libraries, and make sure this third tool in your secure coding toolkit is sharp and ready to go. Thanks so much for joining me on this deep dive, and keep coding securely.